Good morning. Good evening, everybody. It's my pleasure to talk to you today. I'm sorry that I cannot be with you in person, but I hope that you can hear me and understand my talk sufficiently well. You heard yesterday about the general UK government's policy for nuclear development in the UK, and also about advanced nuclear reactors. I frame my talk today about the UK's approach around the concept of regulatory elegance, which I hope will stimulate some thinking. Next slide, please. This talk is my personal view, although I am indebted to Tim Parks of the UK's Nuclear Regulator Authority, ONR, for use of his material. So what will I cover? I'll try and explain what I mean by elegance. I'll explain what is the UK's nuclear regulatory regime and what work has the UK nuclear regulator done on ONRs, and then touch on some issues with some conclusions there. I'm afraid I will not do justice to all of the material given the time constraints, but it is there for you to peruse at your pleasure. Next slide, please. The elegance of ANRs. Major events over the past decades is not prevented by sophisticated safety systems. So have we got a more fundamental approach for ANRs? You remember that famous quantum mechanics theoretician is alleged to have said that if a theory is not elegant, it's probably wrong. What is elegance? It's about simplicity and beauty, perhaps in Japanese philosophy, wabi, of less is more. Not more and more safety systems or features, but safety based on fundamental principles like fault-tolerant fuel, negative temperature coefficients, and passive cooling. And a lot of this, as we've heard just now, will be based on passive or inherent safety. Next slide, please. So what is passive and inherent safety? Well, if we look at the UK regulators' safety assessment principles, I explain that passive safety is provided maintaining a safety function without the need for an external input, such as activation, mechanical movement, supply of power, or operator intervention. Whereas some more fundamental inherent safety is preventing a specific harm occurring by using an approach, design, or arrangement that ensures that harm cannot happen. For example, a criticality safe vessel there. These are from the definitions in the ONR safety assessment principles. Next slide, please. What is the UK nuclear regulator system? Well, it's goal setting. It's non-prescriptive. The goal is to reduce risks so far as is reasonable and practical. So it is based on risk. It's based on licensing permission, based on actually 36 license conditions. Essentially, all these conditions are used for all types of nuclear facilities, nuclear power and research reactors, nuclear chemical enrichment plants, radioactive waste sites, nuclear submarine refueling sites, etc. And they will be also used for advanced nuclear reactors. They're not detailed rules. They're safety assessment principles and guidance for the regulators' inspectors to use as a basis for decisions. ONR itself covers 5 areas: nuclear safety, nuclear security, nuclear site conventional safety, nuclear safeguards and transport of nuclear and radioactive material. Other regulators cover the environmental aspects, the Environment Agency and Natural Resources, Wales there. Next slide, please. What is the UK's nuclear work on advanced nuclear technologies? Well, it's based around 3 elements, 1 to 3 there. Developing regulatory capacity and capability, having the resources to do it, reviewing the regulatory guidance and processes, and thirdly, engaging with industry and regulators overseas and international organizations. Of course, it needs funding. It's not possible in the UK system to get the funding from the vendors, such because they're not applying for a license at the early stages. But so far, we've had up to £12 million from the government. That is the funding approach that I'll explain next. Next slide, please. In October 2017, the Government Department for Business, Energy and Industry Strategy awarded £5 million to develop the capability and capacity to regulate ANTs. The project covers small modular reactors, light water reactors, and advanced modular reactors. In 2018, September, it selected 8 organizations, the government, to produce AMR feasibility and development studies. You can see there advanced nuclear reactor concept, sodium fast reactors, high temperature gas reactors, molten salt reactors, and lead fast reactors as well. In the May of the next year, ONR and the Environment Agency provided advice to the government departments on the regulatory aspects of those feasibility studies there. And in July 2020, 3 AMR projects were selected and a further £2.7 million were awarded to the regulators for early engagement with vendors. Next slide, please. So how do the regulator engage? Well, the vendors submitted to regulators a document explaining their design and setting out their awareness of UK regulatory expectations, the level of design development, understanding the strengths and potential safety, security, and environment challenges, and development and knowledge gaps and intention to address them. The regulators developed a set of regulated themes against which the multidisciplinary team assessed the vendor submission there. And of course, we graded them according to how we thought they aligned with our and understand of our regulatory expectations. Regulators provided advice to the government on our confidence in the potential of the vendor designs to meet UK regulator expectations. Next slide, please. Following completion of this phase, BES selected some AMR, advanced modular reactor fission products for further development engagements, Westinghouse, lead-fueled reactor, and new batteries, high-temperature gas reactors. And again, the government funded the regulators to deliver a series of structured technical engagements with the following objectives: to answer their queries, to identify technical topics for further engagement in phase 2. And this allowed the regulators to get a better understanding of the AMR designs and to allow the vendors to gain a better understanding of the UK regulatory expectations. Next slide, please. How did we engage? Well, we engaged, the regulators engaged through 4 stages. But firstly, through a webinar on key topics and expectations, and then feedback to vendors on their submissions. With targeted engagement with successful vendors on technical topics, and then final vendor engagements there. Next slide, please. The government developed an ANR research development and demonstration program. You'll notice that it's through a different government department that was created really to focus on energy security and net zero targets as announced as part of the policy of government. This was in 2021, and the intent is to move to a high temperature gas reactor demonstration. It's providing funding via competition and with the intent to deliver a demonstration reactor by the early 2030s. The time is split into 3 phases, August 2022 to March 23, the phase B, April 23 to March 25, and then phase 3 to drive to the demonstration reactor from 2025 thereon. Next slide, please. It's a split in the phase A work covered front-end engineering design for two proposals in terms of two lots. Lot 1 was high-temperature gas reactors, and Lot 2 was the TRISO fuel manufacturers there. We had 4 proposals there for Lot 1 reactors, with the lead organisations U Battery Developments Limited, Ultra-Safe Nuclear Corporations, the UK's National Nuclear Laboratories, and EDF Nuclear Generation Limited. Lot 2, in terms of TRISO fuel, was 2 proposals, and lead organisations were Springfield Fuels Limited, based in the north of England, and the National Nuclear Laboratories Limited. The regulators provided advice to government following the same process for the ANR Phase 1 competition. Next slide, please. The government launched Phase B in July 2023 with up to 55 million to support the further development of 2 reactor designs and 1 TRISO fuel manufacturing proposal. In Lot 1, those reactors of 2 designs, USNC, NNL, and with our Japanese colleagues with JAEA. Lot 2, fuel production, 1 design, NNL, again, National Nuclear Laboratories, with Urenco, and also our Japanese colleagues, JAEA. And the approach was to include 6 regulatory touchpoints, provision of tactical reports on specific topics for regulatory review and advice there. Next slide, please. This is just to illustrate the Phase B engagement process. And we set out, the regulators set out their expectations at least 1 month before the submission of a topic report. And then the vendors gave a presentation 1 week before the topic report submission. The topic report submission, after which the regulatory review provided comments within 1 month after that submission, and the vendor's response within 2 weeks there. And then finally a workshop to look at any remaining issues there. And of course, looking at this, you can see that timescales seem short on this. Next slide, please. As well as engagement on AMR's vendors through the AMR program, the regulators have developed a 3-stage process for engagement with vendors on mature SMR designs. And the Rolls-Royce SMR, GE Hitachi, NuScale, and 1 from EDF UK. You can see that this started off with industry engagement events, some key topic seminars in February 2018, including what is understood and what the regulatory expectations are under the goal of so far as is reasonably practical in terms of risk reduction being the overall goal of the regulatory process. And then the 3 stages, opening engagements there to get communications correct, introduction, and then stage 2, our main engagement there with design and operation, nuclear safety, nuclear security, and environment. That was taking place between July and November of 2018. And then the stage 3, a closeout engagement to look at any outstanding actions and advance understanding of future work. That took place during January and March 2019. Next slide, please. Just to look at the benefits of this early engagement and recognizing it's occurring way before any site licensing involvement there. And for the vendors, they get a deep understanding of the regulated process and routes to deployment, and understand what the regulatory expectations and requirements for such justifications. Receiving regulatory advice and guidance ahead of entering formal regulatory processes, so de-risking later project stages. For the regulators, they understanding the technology better, its proposed deployment and operation, and the status of the safety, security, and environment justifications there. And it gives the regulators a basis, a firm basis, to advise government regarding the readiness of designs to enter formal regulatory assessment through licensing processes. And of course, this allows a potential acceleration of formal design assessment process, allowing to reduction in time needed for technical and regulatory familiarizations. Next slide, please. The main process that the UK regulator has been using recently for large power reactor applications is a generic design assessment approach. The generic design assessment approach is an upfront stepwise assessment of a generic reactor design undertaken jointly by the regulators, the Office for Nuclear Regulation, Environment Agency, Natural Resources Wales. Developed in 2006 as a process for regulated assessment of candidate new power reactors on a generic basis. That meant that you didn't have to have a site-specific application, but you could do it for any site in the UK at that point in time, before going into site-specific regulatory assessment under a nuclear site license application. It enables the identification and resolution of key issues on safety, security, environment protection before build commences, so reducing the potential program in terms of cost and time and risks to future builds. It's not a mandatory process. Organizations can go into the formal step of applying for a nuclear site license, but it has significant benefits. And the GDA process has evolved from learning from its use. Next slide, please. As part of the approach to reviewing the processes and guidance for advanced nuclear reactors, we looked at, the regulator looked at modernizing the GDA approach so that it covered safety, security, and environmental impact in greater in a more appropriate way for advanced nuclear reactors. And it included 3 steps to reflect increasing design maturity. Step 1 scopes the assessment of seeing what the issues are and finding out what the approach and claims are. Step 2 indicates of confidence that design can meet regulatory expectations. And step 3, design acceptance phase. Next slide, please. I'm afraid this slide is a little bit complex here, but essentially it shows the involvement of the 3 steps going to in the GDA process. And then the outcome after each step is results in the regulators issuing some sort of statement there. And at the end of the 3 steps, it could, if it's successful, it's a design acceptance confirmation there. Next slide, please. So this just gives an outline of the modernized, if you like, or the approach to the GDA process for advanced nuclear reactors there. It's, as you can see, it doesn't mean to say that it will get through it. And at each stage, it may be that it results in somebody pulling out. But it is intended that the successful outcome will be a clean statement of design assessment there. Next slide, please. Just some indications of the benefits of this modernized GDA process for advanced nuclear reactors there. It increased flexibility and confidence for industry. The statements after each step allow the vendors to manage stakeholder confidence through the process and also gain confidence that their investment in time and resources will be successful. Step 2 statements confirms in principle the acceptability of the overall design to UK regulatory expectations. And it allows vendors to gain early confidence in the acceptability of their design prior to making further significant financial and resource commitments to detailed assessment. And it provides industry with confidence to enter into site licensing process, as I've said before. The detailed assessment of design equivalent to step 2 will still need to be undertaken prior to the start of construction and formalised through the presentation of pre-construction safety report. From a regulator's perspective, it allows the regulators to manage the scope to ensure a more meaningful assessment, which is risk-informed and targeted. Next slide, please. Excuse me. The ONR has fully engaged internationally with other national regulators and international organisations, making the full benefit of the excellent work that's done from our colleagues in the regulatory community worldwide, especially collaboration with our Canadian and US colleagues to identify common principles and approaches. Comparison of industry engagement, how we talk to them, how we do design assessments and licensing there. Also specifically on TRISO fuel qualification there and a high temperature gas reactor operation and experience exchange in terms of regulatory involvement with the vendors. You'll notice that the ONR has engaged with a whole variety of international organisations through IEA technical consultative meetings, application of how the standards and guides to SMRs and AMRs, and also with the Nuclear Energy Agency through the CNRA working groups on safety of advanced reactors, and specifically through the SMR Regulators Forum there, and the IAEA's Nuclear Harmonisation and Standardizations initiatives. Thank you. Can I have the next slide, please? Just an example of some of the trilateral collaboration with our Canadian and US colleagues. First of all, on the TRISO fuel projects, to work together to establish a common position on the fuel qualification based on existing knowledge and to identify any potential analytical or testing gaps which might need to be addressed to enable TRISO use in advanced reactor licensing application. ONR's participation has allowed it to discuss regulatory position and gain valuable learning which will support its programme on the AMR R&D programme. Next slide, please. Now I'd like to move on just to address a few issues. Perhaps in my mind, the move to more elegant designs in ANRs may lead to some issues for the UK regulator, how to assess them, how to balance them against the normal expectations there. First of all, safe by design fuel. How do we assess that and how do we take account of its inherent safety there? Integrated reactor vessels. How do we address that? How can you be certain that the aims of such a feature will be indeed delivered? Also, how do you address passive safety systems and inherent safety? What about the impact on diversity, redundancy, segregation principles, single point failure, or defence in depth principles? And of course, as we've heard previously, emergency arrangements. Just as an example, if you look at defence in depth for SMRs and advanced nuclear reactors, there has been questions says, well, how do you apply it? Should you apply it? Perhaps the answer is to say, well, yes, you apply the concepts and principles, but when you look at the measures to beat them, these may indeed vary. It may indeed be that the level 5 requirements for mitigation measures off-site are no longer required, but some measures might be needed to provide assurance to the public there. And of course, in the UK nuclear regulatory regime, how to demonstrate adequate safety through law principles and showing that risk has been reduced so far as is reasonably practical. Of course, we as the UK regulator has some experience of these, but nevertheless it's reviewing its approach in how it's doing this. Next slide, please. So, as a review of the regulatory framework, just as an example, through 2018-19, ONR reviewed its regulatory framework to check it would be suitable for regulation of Gen 4 technologies. The review looked at each technology in turn, focusing on specific technical areas relevant to each type of reactor there. They considered ONR's guidance, principally the safety assessment and security assessment principles, and the underpinning technical assessment guides. It was a focus area of Phase B of the government's ANR RD&D programme, with the development of targeted guidance in technical assessments guide, helpful for the regulation of high-temperature gas reactors. Next slide, please. As I mentioned earlier, the safety assessments are essentially technologically neutral, currently used to address both gas-cooled reactors and light water reactors, as well as nuclear facilities. Previous versions of the SAPs were used for prototype sodium fast reactor at Dounreay in the early 90s. So throughout the decades, the UK's regulated system has been technologically neutral, and therefore, looking at them, it should be no surprise that there won't be major changes required for the advanced nuclear reactors. For high-temperature gas reactors, some areas may require modification, however, principally around reliability claims, graphite reactor cores, reactor core approaches, and the basis of the physics in there, and of course fault assessment analysis as well. In terms of the security safety assessment principles, it will depend on the level of enrichment in the fuel. It may impact on them, and also safeguards guidance with potential transport there. Next slide, please. So there may be some impacts on the detailed technical assessment guides to inspectors, which will be broader than on the safety assessment principles. The regulator expects that either updates or additional annexes will be required for a number of technical assessment guides. Some examples, but this is not an exhaustive list, are on the safety of nuclear fuel in power reactors, safety aspects specific to spent nuclear fuel, and the chemistry of operating civil nuclear reactors, and also on safeguards technical assessment slide. Next slide, please. So what do I conclude from this? Well, that elegance in advanced nuclear reactor design brings challenges for the regulator. at least in my opinion, a goal-setting regime with technically knowledgeable, neutral principles facilitates accommodating highly diverse nuclear technologies. Nevertheless, some adaptation of existing assessment principles and guidance may be necessary. But it also provides an opportunity to learn from the past and to update existing regulatory approaches. Early engagement is highly beneficial, but at least in the UK system, it needs government funding to take it forward to the extent that is needed. And lastly, but not least, that international engagement with other regulators is vital. Thank you very much.
ありがとうございました。それでは会場からお一方ご質問をお受けできそうですが、いかがでしょうか。はい、ではマイクをお持ちいたします。お座りになったままでも大丈夫ですよ。はい、お願いいたします。
ご講演ありがとうございました。お聞きしたいのは、ANR に対して規制を改善していくと。で、それで、そのアーリーエンゲージメントをやるというのは、いろいろな利点があると。で、それは産業界にも規制者にとっても利点があるんだと。そういうお話は大変よくわかりました。で、しかしながら、それは一方、規制者にとっては大きな新しい負担、その改革をしていくっていうことは負担にもなることだと思います。で、お聞きしたいのは、このような取り組みは、規制 ONR の中から改善をしようという声が上がって進んでいったのか、あるいは産業界から、そういう要望があって、それによって動かしていかれたのか、どういうところがきっかけなのかを教えてください。
Thank you. As I haven't been a regulator for over 10 years now, I can't give you insight into precisely that in response to that question. But I would say that the regulator always looks to improve its processes and its guidance, and periodically would review them as well. And of course, industry, as we've heard many times, looks to greater harmonization and greater standardization there. And I think that we have seen that by being involved in the work on the International Organizations Forum, that has been taken forward there. Of course, that work for ANR needs funding, and that is why the government's funding to enhance the capability and capacity of the regulator has been vital in allowing it to put the resources into any review that is needed there. So thank you for the question.
よろしいでしょうか。ありがとうございます。それではお時間となりましたので、以上でこの講演を終了させていただきたいと思います。オンラインからご講演をいただきましたウェイトマン様に大きな拍手をお送りください。ありがとうございました。Thank you very much.